Let's see, so here's our next problem, problem 2. This is still in the calculator section. It says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. So if I have to do any integration, that would be at time t equals 0. Is f of t is going to be, or f of 0 is going to be 50. That's important, probably. Customers remove bananas from the display table at a rate modeled by this mess. Oh, of course they do. Okay. And so it says from 0 to 12, where f is measured in pounds per hour, and t is the number of hours after the store opened. So our whatever results we wind up getting are going to have to do with pounds per hour, and t is in hours. That's all good to know. So they're keeping it nice and simple for us. After the store has been open for 3 hours, store employees add bananas to the display table at a rate. Okay, so for the first 3 hours, it's just this, but then for the rest of it, it's like they're getting removed and then they're getting added in. And these are both rates. So how many pounds of bananas are removed from the display during the first 2 hours the store is open? So if we want to find out how many are removed, all we got to do is integrate from 0 to 2 our f of t dt. So that's really all it's asking. Okay, so I don't need to go in and actually show what I'm typing. I can just do that, and I'm gonna use my little y1 and y2 trick that I've done before. Let's see, 10 plus 0.8t sine of t cubed over 100. Nope. Do you see how on my screen the 100's in the wrong spot? So I need to over 100 there. Okay, so that should be good. If you're concerned about the parentheses, I'll put them in, but they wouldn't mess with any of that. Okay, so if we go in, we can say, oh, I put that in y2. Whoops, that's okay. So I'll say math integrate from 0 to 2 of vars, y vars, y2 dx. So I got 20.051 pounds of bananas in the first hours. All right. Now we want to find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. So let's see. F is pounds per hour. So if we want, okay, well so we want f prime of 7. So since I'm allowed to use my calculator, I do not need to do this by hand. I may simply go to my calculator and use the integration function. Use the derivative function. I can simply go in and take the derivative of f of x at 7 and get negative 8.1195, which I would round to. Sorry, I forgot the squigglies. So I'd write that as negative 8.120. And so using correct units, explain the meaning of f prime 7 in the context of the problem. Well, if f is pounds per hour, then this is going to be pounds per hour. Remember, or I could write that as pounds per hour squared. And so if we're trying to explain this, then we could say that the pounds per hour is decreasing by negative 8.120 pounds per hour. at 7 hours. I'm just going to double check with the answer and see if that's good. Oh, I need to critique myself. So since we got the negative, I wouldn't want to say it's decreasing by -8. We would just want to say it's decreasing by 8. So, little slip up on my part. All right, let's go to part C. So now we're going to get to the point where we're going to start seeing stuff that's going to mess with us. If the first two parts didn't mess with you already. Let's see. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? So, if we think about this, we want to find out really what's... We know that f of 5 has to do with the rate at 5 hours that they're being removed. And we know that g of 5 is the rate at which they're being added on. So if we find out the rate at which they're being added on and the rate at which they're being removed, we can compare them and see which one wins. So I now need to add in g of x, which should be that 3 plus 2.4 natural log of t squared plus 2t So we're going to compare them. So let's see. I'm just going to go into my table and go to 5. So I already have my table set up, so I can just enter a number in. So if I compare them and I say, so g of 5 is equal to, let me just double check. So in y1 I had g, so that means that in y1 I have g. So g of 5 is equal to 11.533. F of 5 is equal to 13.796. So these are my added per hour, and these are my removed. So bananas, bananas. So if I look at that and I think about that, well, more are being removed than being added. And the question says, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? So we would say the number of bananas is decreasing because more are being removed per hour than added. Wow, added at t equals 5. The way that they say it on College Board's a little bit different, but it's the same idea. They found f of 5 and g of 5, and what they said was, if you take g of 5 minus f of 5, you get this negative number, which is less than 0. And since this is less than 0, the number of pounds of bananas on the display table is decreasing at time t equals 5. So there's a little bit more calculus of an answer, but my reason is valid. So if they had a problem with this, I'd be surprised, because there's no counter argument to this. This is, as far as I can tell, this is an airtight argument, but I wanted just to give a slightly different one than they had. Okay, part D. Part D, probably the hardest part. That's my guess. How many pounds? Oh, I was waiting for this. How many pounds are on the display table at time t equals 8? So if we think about this from t equals 0 all the way up to t equals 12, that's the whole length of time. Well, we only care about up until 8. We know that we are removing all the way from 0 all the way to 8, but we are only adding from if you remember earlier on, we are only adding 3 hours in. So from 3 to 8, we're adding. So basically, we're going to take the 50 pounds that we start with. So we start with 50, and we're going to be adding in from 3 to 8, or g of t, dt. And then we're going to be subtracting out our from 0 to 8, f of t, dt. So this wasn't as bad as I thought it was going to be. So I guess the hard part for this one probably honestly might have been part B, part B or C. So now all I have to do is go in and type these integrals, and you can literally do that in one step in your calculator. 50 that we started with, we added in the from 3 to 8. So on mine, I just need to remember that I had put that into y1. And then we're removing the other one from 0 to 8. And we should get that in the end, there will be 23.347 pounds of 23.347 pounds of bananas. At t equals 8. So, let's talk about the score breakdown on this since I have a couple minutes left. So, in part A, you get 1 point for showing your setup integral, and you get 1 point for giving your answer. In part B, you get 1 point just for getting negative 8.120, or negative 8.1195. So you get a point for knowing how to type that into your calculator. Then you get 1 more point for saying what's going on there. In part C, you get 1 point for considering those two. So basically just finding those two. And you get 1 point for giving your reason. And in part D is worth the most points. Part D is worth 3 points. You get 2 points for this integral, for having these integrals, and you get 1 point for your answer. So this question did not have really any space for units like the last question did.